All right, exponential is actually something that we have already covered before. We're just using a different option instead of the ones that we've already learned. We've already learned how to use we've already learned how to use regression for linear equations and then also for quadratic equations. When you're using exponential regression, or I think the one thing that most people remember about regression is the stat edit. That's when you're putting your points into your calculator. So once again, we've already learned how to use option four. Option four, the words next to it or the letters next to it is linear regression. You use this option when you're talking about straight lines. When you have, if you look at your answer choices are written in slope intercept form where it's y is equal to mx plus b. Or you're looking at a straight line, you find some points on it. The other option that we recently, and I shouldn't say recently because I've had somebody in yesterday trying to turn in quadratic homework. Quadratic regression. Quadratic regression, when the graph looks like a U, it's called a parabola. If your answer choices are in the form of an equation, the unique thing about quadratics is that x squared. It's the fact that it has that squared in the equation. It can be 2 terms, it can be 3. So that's why I'm not writing the amount of terms. Exponential regression, you will actually see it on the inside of this foldable, but exponential regression will be option 0, and it will have an EXP reg, R-E-G, for regression. You're going to use this whenever you have, if you're given only a graph, you're going to be looking at a half curve, whether it's going up or down. Or let's go ahead and write the formula. If your answer choices are in the form of an equation, the unique thing about exponential equations is that your x value is your exponent. The x is the exponent. The x is the exponent. Regression can be used for so many things. It's a very, very helpful tool. So the first thing that we're going to look at is the graph. When given a graph, when the graph is what is given, when it's the only thing that's given, and they want you to find an equation. I'm going to write given in parentheses. What you can do to help is to create your own table. Now, I've actually given you a table, but nothing's stopping you from being productive and finding your own points. Now, obviously, you want to find some good points. And if you look at the very first point that's plotted right here, that's in the middle of something. It's not a whole number. So I would not risk missing a problem over trying to figure out what decimal number that is. I'm only going to pick from the good ones, from the ones that are at whole numbers, at good intersections. So that's a note that I want you to write. What in the world? There we go. So you want to find 2 good points. And the reason I write 2 good points, the reason I write 2 is because on your test review, there's going to be one graph where you can only see 2, but I prefer 3 or more. Prefer 3 or more. I'm a highlight prefer type situation. On some of these graphs, you have no choice. Like there's only 2 good ones, but if you have 3 or more that are actual good points, go ahead and identify those as well. Now, as of right now, we're doing much, much better about putting an X and a Y over your ordered pair that you've identified, and you're putting the X and Y in the correct spot. But now what I'm seeing is that we're flipping the numbers in the parentheses. So you need to be careful about placing the numbers also in the correct spot. X values come from the X axis, Y values come from the Y axis. Look at the x-axis for your number. Look at the y-axis for the number to that point. It's a coordinate. It's a place on a map, if you will. Your tables. On the STAR test, state of Texas has gotten in the habit of putting f of x instead of y, but they're no different. It's still an x and a y table. Don't let that f of x throw you off. And the very first point that you always want to identify is your y-intercept. So let's start there. My y-intercept. Put a little x and y. So the x value of the y-intercept, the x value goes straight down to the middle, making that what? 0. This number right here, even though my numbers are jumping from 2, 4, 6, 8, 10, you notice a line in between these. So every box still counts for 1. So that's at 0, 1. And once again, I only feel the need to go over this again, even though this is 5th grade work, because you guys are now mixing up the numbers. The x value, go down, your x value is the number 1. Y value goes straight back, number 2. So 1, 2. Next point, your x value, if I go straight down, is 2. Y value, if I go lateral, is 4. I go to the left. Next point, x value, if I go straight down, falls in between 2 and 4. The number 3 is in between 2 and 4. X and Y. If I look for my y value, it meets the 8, 3, 8. And that last ordered pair is 4, 16, XY. So once you're done identifying at least 3 or more good points, prefer 3 or more, 2 if you don't have a choice, put those into your table. Put them into your table. Nothing is stopping you from drawing a few lines. Even though I gave you a table here, you could also draw your own. It's not that hard. So 2, 1, 2, 3, 4, 1, 2, 3. And then turn the page when you're ready. You have the points. They're written on your graph. You don't have to look at mine. All right. So the steps are still the same with one exception. The option that we're using is different. Steps are still the same. Start off by pressing stat edit, stat enter, stat enter. You're going to put your X values in L1, Y values in L2, but if they already have numbers in them, you clear enter. You go up to highlight and then press clear, not, excuse me, not delete. Go ahead and put your numbers in. After you put your numbers in, step number, what is it? Step number 3, click stat again. It does say again, click stat again. Scroll over, use the right arrow to go over to calculate. You should be in this screen. In this screen, once again, I just went over it. We've already learned how to use 4 for straight lines, 5 quadratic, you have parabolas or an x squared in it. Now you don't actually see option 0 here. You can always press the number 0 on your keypad. If you forget which number exponential is on, look through it. It will have an EXP next to it, and there it is. But if you remember that it's 0 and not 4 or 5, just press the number 0. This screen should be extremely familiar to you. We have seen it 2 other times before. You go number 5, you go down to store. And in store, I have now actually given you the buttons and they're really printed really big. Alpha trace, alpha trace, alpha trace, enter 3 times. And that's the screen that you should end up with. A equals 1, B equals 2. I'm going to go ahead and write the formula over my final equation, even though I've already given you the final equation, for this reason. I'm still having people, just because we're too lazy to write the original formula, so I don't end up putting the number in the wrong spot. They don't write it, they go straight to writing the formula, and I'm still having people putting the numbers in the wrong spot. Still having people putting numbers in the wrong spot. Here, they're giving you the numbers, they're telling you what variable it's going to replace, and we're still putting them in the wrong spot. A equals 1. Bless you. A equals 1, so that 1 is going to replace A. On the STAR test, I've mentioned over and over and over that they will not put the actual number 1. That's something that is understood to be there. Even though you don't physically see it, you need to know that it is there. B equals 2. That 2 is going to replace the B inside the parentheses. Inside the parentheses. Okay. Now go back over to the front of this page. You could use regression several different ways. Let's say, for example, you're given an equation. You start with an equation. I'm going to write a note. If given an equation, if given the equation and you have to match to a graph. If given an equation and you have to match to a graph, very, very first thing, eliminate based on y-intercept. You find the y-intercept first. You're still going to create your table, but you want to create your table and then eliminate based on the y-intercept. You find the y-intercept right here. And if the y-intercept doesn't match to the graph, get rid of it. Eliminate based on the y-intercept. After you're done with that, create a table with the other graphs. And we're writing this down because you're actually going to have to do, you actually might have to do this on your test review. You're going to create a table with the other 2 graphs, because more than likely you're going to be able to eliminate 2. And then put equation in y equals and compare. In y equals and compare tables. You can do this both ways. You can start with the graph and find the points to get your equation, or you can start with the equation and then find the points and then match it. You would be able to match it by using, so for example, I start with the equation. There's my equation right there. I can go to second table or second graph and match it to the points that I wrote in. Understand? All right. So back over to the lesson. The examples. When you're given a table, anytime you're given a table, specifically with tables and sometimes graphs, the very, very first thing, because we're doing regression, the very first thing I want to look for is, what option am I going to use? Am I going to use 4 for linear? Am I going to use 5 for quadratic? Or am I going to use 0 for exponential? because now we have 3 to choose from. With every table, 9 out of 10 times or 9.5 out of 10 times, they're going to tell you the word exponential right here. So you always want to look for that. That's your very first clue. Tomorrow, for sure, it's going to be this because that's what the test is over. On the STAR test, it's a mixture. So just based off of the word exponential, I know that I'm going to be using option 0 for exponential regression instead of 4 or 5. And we can go ahead and start typing these numbers into our stat edit screen. I will meet you at the final screen because I will not be waiting for you to type everything in and then going back over the steps. You have the picture. You can use the pictures if you forget what to press. Anybody need more time? So what did you get for A? A is 10 and B is 2. A is 10, B is 2. Couple different ways that you can tell whether it's growth or decay. Couple different ways. First of all, which one of these numbers tells you if it's growth or decay, A or B? It's B. B is your factor. B is your factor. B is your factor. And if your factor, if B is greater than 1, that represents what? Growth. That represents growth. But now that we have the equation, we could also just simply look at the graph. Hit graph, and you can see the line going up from left to right, growth. If you go to y equals and there's no equation there in this spot, that just means, that simply means that you did not press alpha trace. So you could also look at the graph to answer this question. But more than likely, it's going to be followed with other questions. So it says, write a function to represent this relationship. To write a function means to write a what? Equation. To write a function means to write an equation. Once again, especially not on the notes, we're not going to be lazy and not write the original formula. F of x is equal to a times b to the power of x, especially with exponentials, because this formula is not on the reference chart. So the more you write it, the more you'll memorize it. What number goes after the equal sign? 10. And inside the parentheses, 2 to the power of x. I've had some people turn in some assignments and it doesn't have the power of x. So make sure you don't forget that. Okay. Before we move on to part C, A also represents something. I have a 10 right here. What else could that represent? It represents your y-intercept. Now, if you look at your some other examples in these notes, you'll notice some blanks once we flip over to the next side, because, and I wanted to leave it blank because not your y-intercept will not always be included. You can find it if it's there, but it's not always included. Okay, based on the data, predict how much bacteria would be there after 6 hours. Hours is a measurement of, and time is your x value. Time is x. So based off of what we learned yesterday, we can replace the 6 hours with our x. F of x equals 10 times 2, and now to the power of 6. You're replacing the x with a 6. And what do you get? $640. Because this is a word problem, because we have titles on our table. We have titles on the table, X and Y. Because there are titles, more than likely your answer is going to require some type of description. So what? $640, 640 milligrams of a medication, 640 bacteria, 640 bacteria. You know that 640 is a Y value because they gave us X. And your Y values are here. So it's going to use this as the description, 640 bacteria. You could always use that to help you as well. D. D is another form of asking you for a Y value. It's still asking the same thing. It's just asking for it differently. Okay. Anytime you see F of something, in your mind, you should automatically be thinking the words F of X. F of X. Now, you should notice, or you should be able to tell that the number 10 is in the same spot as the letter X, as the variable X. So here we are given the X value. The 10 is my X value. We have to find the Y value. We're looking for the Y value. Now, no, once again, it's not 2. 2 is your factor. You could also plug in the 10 here because this is where my X goes, but there is another way because I am using regression and I do have my calculator in handy and I have my equation here. We have learned a way to go directly to an X value of 10. What do we do? Second window. If I go to second window, I can type in my number 10 and then press second graph, and it'll take me directly to the answer. So we could have also done that with the number 6 because my X value is 10. Look at the 6. My X value is 6. There's the 640. But just keep in mind, if you're using this method in here, it has to be to the power of X, not to the power of 6. You don't type this in. You type in the original formula, okay? So what was the answer? My bad. For 10, 10,240. 10,240. 10,240. Now, some of the values or some of the numbers that we're going to use today are going to be pretty big, but they will always fit. So one thing you can keep in mind, or one thing to keep in mind, is if you work a problem out the day of the STAR test and you get a number that's too big for the griddable, you have done something wrong. They will not give you a number that is too big to fit in your griddable, okay? So I'm going to write myself a little note here. Second window, second graph. Second window, second graph. We're not going to write exact steps. We're just going to give in general because we actually have the steps written in our notes somewhere else. Second window, second graph. Second window, second graph. That's all I'm going to write. And what is my Y value in? Y bacteria, my bad. It's just bacteria. We already wrote the description on that one, so we're good. Next one. Number 2. I left this blank for a reason, but these are the only numbers that you're going to type in. So go ahead and type those in. And I will type them in myself on this side. Stat edit. Now, as you're typing that in, I'm going to go ahead and tell you or remind you about your test review, you should now have enough information as of the end of today, as of the end of this lesson, you should have enough information to complete that test review. Now I did write except 19G and H, except 19G and H. Go ahead and leave those blank because even though we've already done domain and range, there's an exception with that one. So but other than that, I have given you all of the information, all of the tools to finish that test review. All right, everybody got your numbers? So A is equal to 0.70 and B 1.49. If it gives you 1.5 on the STAR test, you should be able to recognize it. 1.49 is the same as 1.5. My 4 is ugly. I had to erase it. Yep. All right. I'm going to go ahead and fill in that A right here because that is my what? It is my y-intercept. Now, even though it's not, they don't always give it to me, they can, and I need to be able to recognize it. Does this one represent growth or decay? Growth. I look at the value of B. I know that B is my factor. And if my B is greater than 1, that is growth. If B is greater than 1, that is growth. I had somebody point out earlier, which was, I forgot I had also showed you that, but very, very proud that they remembered. If you know for a fact, like right here, it says the word exponential function. If you know for a fact that it's exponential and you can see that your y values are increasing, 0.70 goes to 3.54. You can see that they're increasing. That's also growth. My numbers increase. My numbers are increasing, so that also represents growth. That is what we did on Monday. That is what we did on Monday. But that's only if it says the words exponential, because if it's linear, that's different story. It is growth. I mean, it's increasing, but different story, different scenario. B, write a function, write the equation, write the equation. Don't be too lazy to not write the original formula. My original formula is f of x equals a times b to the power of x. I have to write it as many times as you write it times 5, because I have 5 classes. So if I can write it 5 times in a row, you guys can write it once for 1 class. All right, so what number goes after the equal sign? 0.70. And inside the parentheses, 1.49 to the power of x, 1.49 to the power of x. What is f of 0? What is f of 0? I'm going to write f of x right above it. So I am looking for the x value of 0. I'm looking for an x value of 0. So I can find my y value. Now you can, and it's okay if you need to use it, you can use second window, but technically you do not have to. Why not? Because we already know what it is. When x is 0, that's your y-intercept. And if your y-intercept is 0.70, if your y-intercept is 0.70, that's the y value. But once again, you can use second window. So 0.70. I probably would still use second window because I'm super paranoid about stuff like that, but yeah. Now, what does the value represent? We talked about describing things when we see the word represent. It represents on a graph, it represents the y-intercept. But in a word problem, what words would we see? initial value or starting amount. Oh Lord, starting amount. I'm just gonna put AMT. Feeling a little too lazy to be an English teacher right now. So starting amount. If you actually have a description, like the first example, we were talking about bacteria, you need to say starting amount of what? You need to be specific. If you look at the table for this example, it doesn't have titles. So we don't even know what the numbers mean. They're just numbers. Numbers are just numbers until you give it a meaning. And there's no meaning behind this one. Ready? All right, go ahead and give me, y'all work out the next problem and I will meet you at the A equals and B equals screen. I'll meet you at the final screen. Now, as you guys are typing these numbers in, can somebody tell me what is a stock? I got like 4 different descriptions, which none of them were wrong. 4 different descriptions. You're like the first one to bust out with that right away. Yes, it says we're talking about the Johnson Company. That's if we read the problem. We're talking about the Johnson Company. There's somebody is investing in some stock. It's an investment. You buy rights, you buy shares to that company. It's kind of like owning a little bitty part of the company. Obviously, they're not going to sell you 50% of the company. You probably most likely don't have the money to buy that, to buy 50% of the company, but that's what people do. They buy parts of the company. They buy shares and they use that for their, sometimes it's a risk. Sometimes that money accumulates, but sometimes it doesn't. Sometimes you end up losing money. You buy it for a certain amount, and that if the company does well over the years, maybe in 10 years, 20 years, you'll get some more money than what you put in. In 10 to 20 years, if that company goes down, if they start sucking it up, then you'll probably end up losing money. So just a little life lesson, I guess. Everything's a risk. It says the table represents some point on an exponential function. So always look for those words, always highlight that. What do we get for A equals? 120. What did we get for B? 0.95. All right. If B is 0.95, we know that's the factor. And that number, B, is less than 1. So what's happening here? Decay. We see decay. What is the value? What is the value? We talk about, bless you, what is the initial value, the initial Y value? If we're talking about value, they want a number. What's the initial Y value? 120. And that 120 is a Y value, and we're talking about stock. It's in, we describe it as money, $120. So I bought, let's say I bought part of the company for $120. That's my zero, okay? Now, is this showing, no, what is the factor? The factor is the number where? In the parentheses. So my factor is 0.95. That is my value of B. Let's write a function. Let's write an equation. F of x equals A times B to the power of x. So 120 goes after the equal sign. 0.95 goes in the parentheses. Said, what is the estimated stock value in 10 years? Years is a measurement of time. If it's time, it's an X value. So once again, You can find that number, you can find that value, that answer two different ways. You could either plug it in for X, you could plug that X value in for X, or you can use second window, second graph. Up to you, go for it. What is the value? I know 70 something. Whoa, 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 what? 71.85. And 71.85 describes what? Bunnies, rabbits, what? Stock value, dollar amount. It's a Y value. It's in dollars. So over 10 years, what happened to my investment? Did it go up? Did it go down? So would you invest money into this if you knew that was going to happen? Nah, I'm losing money. All right, last one. Last one, quick one. First, highlight or underline your exponential function, and then find your A equals and B equals. Notice in this table, you don't see your y-intercept, so I can't find A right away. I actually have to type it into the calculator so I can find the regression. So I can find my equation. And some of us already have it, so let's move right along. What is A? And what is B? Okay, so we're gonna write our original formula. The more I write it, the more I memorize it. 5 goes in front of the parentheses, 0.25 in the parentheses. A, B, alphabetical order, A, B. B and C, the word evaluate. Evaluate is once again another form of asking for the Y value. This is just another way of asking for the Y value. You're given f of -5. The -5 is in the same spot as X. -5 is in the same spot as X. So the question would be, what is my Y value? What is my Y value? Go ahead and find that number. 5,120. You can use second window, second graph, or you can plug your -5 in right here. You can plug a -5 for your X. Two different ways. Two different ways, because I already had somebody that preferred plugging it in, didn't understand second window, second graph. So either way works. -8 is also, once again, in the same spot as X. So you can plug it in, or you can use second window, second graph. What number does that one give you? Ooh, 327,680. Once again, the star test will not give you a griddable that's not big enough for you to bubble it in. So if you have more numbers than griddable boxes, you need to work that out again. Okay, so this one, the one with your exam, okay, steps goes in 126, examples into 127. Steps in 126, examples into